Good evening, everyone, and a warm welcome to you. Thank you so much for joining us for this AI for Africa, empowering your future in the digital age. My name is Kiki Rebecca Lawal, and I'm honored to be your host today on behalf of Hesed World. Over the past few months, through our fireside chat in Kenya, Malawi, and Nigeria, one thing has stood out. Young people across Africa are not only curious about AI, you're ready to learn, ready to innovate, and ready to lead. But we also know that access is a real challenge. Many students are now on holiday, and that means losing access to free campus internet. This continues to be a barrier for young people across much of sub-Saharan Africa. That is why we're also streaming this event live on YouTube at Hesed World. So more people can join flexibly and revisit the content later. Please feel free to share the link. Now, a word to those of you who may feel like the world is moving faster than you can keep up, or like you're running out of time. I understand, but let me gently offer another perspective. What if the waiting is not a delay, but a training ground? The place where skills are built, where character is shaped, where resilience grows. We all want results now. That's natural. But often it is in the small steps, the daily learning and the consistent effort that real lasting success take roots. And that's why today matters, because we're joined by someone who understands both the pace of innovation and the power of process. Please join me in welcoming Mr. Oz Ozturk. He's a globally respected expert in AI, digital transformation, and emerging tech. He's a partner and AI leader at PwC, and where he has led strategy across Europe, the Middle East, and Africa. And he also worked closely with partners like Google. But today, he's not here in his corporate role. He is here personally because he believes in you. And he shares our mission to empower African youth with digital skills and opportunity. Oz has led many projects in the past, including education, healthcare, finance, and he's passionate about making AI truly accessible to communities like ours. Today, he's here to demystify AI and show you where to start, as well as offer practical tools to help you move forward with confidence. So get ready, ask questions, take notes, and share ideas. Let today be a beginning, not a finish line. Thank you again for being patient and for being here. Oz, over to you. Thank you.
Thanks, Kiki. Thanks for the wonderful introduction. I'll do my best in demystifying. I may be mystifying it even more so, but let's hope for the best. Look, thank you everyone for this opportunity. As Kiki mentions, I'm very passionate in this field of AI. You get to see what businesses need, how people use it, and hopefully I can share some of those learnings and reflections with you today. I don't have hundreds and hundreds of slides. We're not going to go through all the maths behind these solutions, but what I'm hoping to do is arm you with enough knowledge that you can be dangerous. You can use it as a platform to educate yourself and also be curious about this field and think of it as a bit of a storybook, a bit of a guidebook on how to navigate the field of AI. Okay, so that's kind of the objectives of today. Kiki already introduced who I am. I'm a partner at PwC in London, but I've worked across the globe, and I've worked for many other organizations, all in the field of technology. And I'm really excited by this field because it's moving so fast, and it's, there's new solutions coming out, and there's a lot of ambition and, how should I say, inspiration when you start looking at what's coming down coming down the road in this field. But before I kick off, Kiki, I think, asked all of you, what was your interest? And I've seen some of the initial, the questions that were fielded of what people would like to learn. But I'd like to spend maybe just 60 seconds, a minute, if you can put in the chat, just some key things you're looking for. Give me some key words or key areas that you'd be interested in, and hopefully I can touch on that during the next 90 minutes or so, or 80 minutes that we have. So why don't you spend about 1 minute, all of you, just going into the chat box and just giving me a view of why you're here this evening. It's very quiet. I can't see anything in the chat. And it can't be Kiki asking all the questions, by the way. Everyone's a bit shy, Kiki. I think you're going to have to prod people, or... Okay, one, to understand the challenges. Another in education. Great. Everyone's a little shy on a Thursday evening. But look, let me just say, there's going to be a lot more that I'm going to show you than just those things. And here we go. Ethics, that's a good one. Practical insights. Environmental concerns. Yep, great questions. Excellent. All right, we'll cover them and quite a bit more, hopefully. So let me use that as a segue to the agenda. There's really 6 sections I'm going to go through and give you a flavor for AI. So we'll touch on what is AI, and I'll walk you through some definitions. You would have been familiar with some of them, maybe you're not, but we'll start from a baseline level to get everyone on the same page. Then we'll touch on the building blocks of AI. There's a bunch of, I would say, foundational elements that you should just be familiar with, and I would implore you to go and do some research and reading post this session to get a better understanding of some of those terms and technologies and capabilities. I'll walk you through where it's going. It's quite exciting and scary and worrying and, ambitious all at once. So we're going to have to navigate, that path. And from there, I'm going to try to make it real for you. I'm going to take you through a number of demos. I've got quite a few, actually, and we're going to do them live. So fingers crossed, so you're going to actually see some of this stuff in action. Then talk about the opportunity for Africa. There's some real areas where AI is very applicable and relevant. And then finally, we'll talk about some of the resources that are available to you in Africa. And again, you can use this reference guide to act as a bit of a cheat sheet to go to those resources and get a bit deeper into the field of AI. Okay, sounds good. And Kiki, just give me a thumbs up if you're if the volume and everything is okay. You can. Great.
I think it's good.
Yeah. Great. Thank you. Okay. So what is AI, right? Everyone throws around AI. There's a lot of AI washing going on. But actually, what is
The
it?
volume went down now. Start again.
Okay. Can you hear me now?
Yeah.
Okay. So what is AI? What is artificial intelligence, right? But fundamentally, it's a field of computer science. And there's a whole bunch of tests of what makes good AI, but essentially we're building machines which can perform tasks humans can do. They can learn, they can reason, they can perceive, and they can interact. And they do this on a foundation of data. Okay, they understand the data and they interpret that, they reason from that, they perceive it, and then they interact with the users, being people like us. And that data could be in many forms. It could be text, it could be voice, it could be images, it could be video, right? What people call multimodal. What you're all experiencing today is what we term narrow AI, right? Which is the models have been trained on a data set, and the output that it gives to you, when you interact with it, is based on that data set. So it's very much geared around specific knowledge, and it translates that or transforms that knowledge into a way that it can respond to your prompts and needs and asks. Okay, what it isn't, it's not self-aware. It's not thinking in the background whilst you're having a cup of coffee. It can't talk about everything under the sky, and it's not sentient anytime soon. Okay, but that's the term that you would have heard around general AI, which is where a number of leaders in this space are really trying to aspire to. Okay, but we're a little way off that. Makes sense? Okay, so how should you think about this? I always like I'm a big Lego fan, and I always think of AI as Lego pieces. There's all these little building blocks that you actually have to pull together to make AI work. Okay, and it's a nice analogy in terms of, or a nice concept to think about when you want to implement or deploy AI solutions. Right, there's not one single component that will give you the answer. You have to pull all this together, and it's not actually built with a manual. Right, it's not readily available. You have to orchestrate and build or pull these components together using expertise and knowledge and multidisciplinary skill sets. It's also been around for quite some time, so everyone would be thinking that AI didn't exist before 2022. When you got your personal exposure to ChatGPT, that was probably your watershed moment. But the reality is AI has actually been worked on for over 70, 80 years. It actually started off with some mathematical concepts called the MCP in 1943, where an artificial neuron was created, which is like a neuron, like similar to to mimic a decision kind of a tree model within a human brain, and that was conceptually and theoretically designed in 1943. Then you have Alan Turing, some of you have heard about, who invented or proposed the imitation game, where you actually propose, like, we've achieved artificial intelligence when the computer, you can't tell the difference between a computer responding or a human responding. It was a famous, if you slip a piece of paper under the door, would you know that it's a computer giving you the answer, or would you know if it's a person giving you an answer? So it was actually a field of research and theoretical science, very, in the mid-century, right? So quite a while ago. Then in the 50s, specifically one year that stands out is 1956, where four individuals, quite high-profile individuals, a gentleman by name John McCarthy, Marvin Minsky, who some of you may know or not know, but have heard of. That was the first time artificial intelligence was actually coined, and that's quite a funny story. They said they were going to solve AI in an 8-week summer project during universities in the US, like it's similar today in most around the world, is that you'd have a summer break, and these very smart individuals thought, what do we do with our summer break? Let's invent artificial intelligence. So it was quite an ambitious task, but that's when it was first coined. Then governments saw opportunities around this and put a lot of funding during the 1960s and 80s around research, and it was very much focused on what we would call expert systems. So can you model a way a particular expert performs their function, let's say a doctor, and all the decisions they make, and can you put that in some type of system? And that actually wasn't that successful because there was a lot of things that weren't around in those days, compute power, data, lots of, I would say, human resource, the funding that goes with it, the methodologies that go with it. So in the 1980s, what happened was what we would call an AI winter, and this is where people lost interest in the field of AI for about a decade. It wasn't very popular. In the 1990s, it started coming back again, with the advent of internet and e-commerce and data proliferating across the ecosystem. The concept of machine learning came about, and I'll talk a little bit about that later. But essentially what machine learning is, it's about when you take, a set of data, you create some, rules around that data, and you make predictions from that data. Okay. And that finally evolved into what we call today is deep learning, right? You would have got your first exposure to that with things like, the chess championships, where IBM's computer beat the world's best chess player. You would have seen it with AlphaGo, etc., etc. But the field of deep learning is really what AI is built upon. Okay, and then some of the breakthroughs there were things like AlexNet in 2012, where each year there was this image challenge, right? Can you recognize an image? If I show you a picture of a cat, does the machine know it's a cat? If I show a picture of a tree, does it know it's a tree? What kind of tree? And in 2012, that's when, the performance of those capabilities were, far exceeding what was envisaged. There's a particular field there of what's called CNNs, right? Again, we'll touch on that a little bit later. Okay, so the message I want to leave you here is that this has been around for a while, but why has it actually become so popular, or so? Why did it just, come to birth all of a sudden in the last decade? The real reason is, what I would call convergence. So convergence of data, compute, networks, computer science people. All these things were happening in parallel. Hardware and infrastructure was getting better. Data was proliferating. Network connectivity was, the bandwidth was basically increasing. The field of computer science had a lot of foundational research behind it. And then fundamentally, you had people who are really passionate about it in many parts of the globe. So it's this convergence which has really made this possible. This is a screen grab of that proposal of that summer research program. These are the four individuals. John McCarthy actually went on to lead Stanford's AI Institute. Marvin Minsky is very famous in his field. There's Rochester from IBM and Bell Telephone Lab. So these individuals kind of knew what they were talking about, but they were probably a little ambitious with the 8 weeks, because we're still here and trying to figure it out. So when you create an AI model, some fundamentals you need to know about. You need to say, what am I trying to achieve? What's my goal? What kind of data do I need? You got to collect that. You got to clean it and prepare it. Then you train a model using algorithms. You test whether that model is actually behaving that you think it needs to behave through benchmarks and performance management and testing. When you're happy with that, you deploy it. And then you need to continuously monitor it, right? Because they don't necessarily do everything the same way every time you ask them to do a particular task. Okay, which some of you have probably experienced when you've been prompting or using some of the models out there. But this is a really simple way of thinking about, what you need to do to create an AI model. Now, there are lots of components to this, and I'm going to just touch on some of them. Okay, so I don't want to scare you. I'm going to provide all these resources to you after this call. I'll give them to Kiki. We'll package it up. You'll obviously have the recording, but you'll also have some of these links and materials. Okay, so don't worry too much about absorbing everything. But let me kind of move to a section on concepts. Okay, you can see my screen here. So these large language models and these foundational models that you're being exposed to, they're all based off some raw data coming in. That data then has what we call a vocabulary. It's actually tokenized. It's broken down into components that the computer can actually absorb and understand and read. And we'll talk a little bit about that later. It runs through a neural network of sorts. It gets trained, and training includes not just a computer, but humans actually looking at it and saying, is it doing what we expect? They verify it, they look at the data, etc. And then there's different types of learning, right? And this is quite important to understand, right? There's things like supervised learning when you're building these models. This is where you label the data and you make predictions. There's unsupervised, where the machine basically identifies the patterns. And there's reinforcement learning, where it actually interacts and tries to maximize. It learns essentially from different layers in the network. AI is this one broad field. AI is made of machine learning, which enables systems to learn from data without any explicit programming. And deep learning is a smaller subset of machine learning, right? So that's kind of how you should think about it. It's like concentric rings. AI on the outside, within that machine learning, and within that deep learning. Okay. And then when you to enable these models, like you would have experienced models which create images, or you would have experienced models which create a video, you would have experienced translation models, etc., etc. They're actually they come into existence because some capabilities, right? In 2017 or so, this concept of a transformer was actually built by Google, and everyone adopted it. And what this allowed the machines to do was effectively take large volumes of data, process it in a parallel way, and understand the relation of words and characters to other words. Okay, and I'll demonstrate this a bit later for you. CNNs, is a neural network which effectively analyzes and identifies images, and diffusion models does the reverse. It actually creates images. It creates images and videos. Okay, but as I said, go and explore these topics. And then large language models adopt these techniques when it comes to prompting. And you would have seen some of this when large language models were, first released. You had to be like an expert prompter to get the best out of it. A lot of that functionality now is being built within the large language models. So in deep research, you see things like chain of thought prompting, where it actually, the machine defines the step of prompts that need to be taken to create an answer. You'll see embedded MOEs, where the machine actually says, what is the best part of this model that should answer this question. So it's almost like finding the expert within the machine, not the ghost in the machine, but the expert within the machine. And then there's, prompting advancements where you could ask one question and it knows kind of what you're asking, et cetera, et cetera. And this will continue to develop and be further embedded in these models. Okay. And then you have all these technologies underlying that make this happen. I won't dive too deep in there, but things like RAG, where you can actually anchor it around some knowledge, APIs, which allow you to connect to different data sources, the GPUs, which actually power all of this, and some of the orchestration and platform tools to actually make it all sing and dance together. Okay. And then the future where this is going, which we're going to touch on a bit later. You would heard of agentic, there's robotics, there's spatial reasoning, and there's things like neuromorphic computing. But this is kind of the ecosystem that you're, how should I say, working with. Okay, so I'll leave those resources and leave these things food for thought for you. But it's just important that you understand some of these concepts. Now, let's kind of bring some of that to life, right? What's the difference between deep learning and machine learning? With machine learning, the core ambition is, or what I said, the core process is that you'll do what we call as feature engineering. You'll say in this image of the cat, all the different parts of the cat, what they represent, and you'll effectively program, right? Or you'll teach the machine. These are all the different components. When you see these images, use these components to identify whether it's a cat or a dog. Okay, so it's somewhat deterministic in a way, right? And I'm sure some statisticians and mathematicians will say that's Oz, what you're saying is completely wrong, but you kind of get the gist of what I'm trying to tell you, right? You define the features of the cat and it will identify whether it's a cat or not. Deep learning actually understands and learns on what the different types of the cat are. And it requires an enormous amount of data to do that, but that's the difference between deep learning and machine learning. So if you have lots of data, you'll see opportunities for deep learning. If it's small amounts of data, you'll see machine learning is more relevant. Okay. And then what's the difference between diffusion models and CNNs? Well, CNNs basically analyze the picture and they say it's a dog, right? Diffusion models say, I will ask it and say, create me a dog, and it'll have a view of what a dog looks like, and it'll slowly start creating a dog using a diffusion techniques like you see in that picture there. Now, I've created some Easter eggs in this deck. One thing I should tell you all, I created this whole deck using AI, right? It wasn't as easy as it looks or seems, right? It's not like I said, a prompt, please create me a deck for this lecture, and 30 seconds later, everything kind of landed, right? It probably took me about 3 or 4 days, but it still helped me. But there's an interesting Easter egg here. If you look at this dog picture, it says dog at the end, but it is a strange word, fettertupt, right? Some people will be thinking, what's that technical term? You're probably actually trying to find out, like, what does that mean whilst I'm speaking. That is actually an error in the model. When I was using, a large language model to create a picture for me, I said, create a picture for me that represents a CNN and how it works. It came up with this picture, but as it generated that picture, it also incorporated random text, right? So this sets the path of some of the challenges, issues, and things you need to consider as you think about it. You'll see another Easter egg there. It says noise and noise in the other dog picture on the right. And then it says generatestic from noise. What it probably wants to say is generated from noise, but it's, again, come up with random words. And this is one of the challenges in image generation with large language models, they actually quite fall over when you start combining images and text in that image. Okay, so it's a nice and interesting thing to kind of look up and test. Now, one last concept I wanted to leave you with was this concept of the transformer. And I've tried to, and it's not the transformers that some of you may be familiar with or I grew up with. You know, we're not talking about Optimus Prime. We're talking about a piece of technology which actually interprets words and their relationship to other words, right? So I've tried to do something here which says, okay, how do I explain this, right? So if I took a sentence, she served the jollof rice with fried plantain, but I only ate it because I don't like dodo. Okay, so how does the computer actually interpret this sentence, right? It needs to understand the relative importance of words to other words within that sentence, and it needs to understand which word is the most important and what is it referring to, where is the anchoring around it. And that's the concept of, that's what the transformer does. It allows you to interpret that sentence, and it uses what's called an attention mechanism. Right? So when it looks at the word it in that sentence, it's saying, is it referring to the jollof rice? Is it referring to the plantain? Is it referring to the dodo? What is the operative meaning of this sentence? And it'll determine the link between it and jollof rice is the strongest relationship, whereas plantain is weaker. Okay, so this is really an interesting field of research and science, but this is essentially what allowed large language models to exist. If this did not come to fruition, we would not be talking about large language models today. Okay, so spend a bit of time on that. So where is it going? Look, this is where it gets really interesting. As I talked about convergence at the beginning, that's just going to accelerate. There's going to be more convergence. We're going to see some of these models get bigger, but actually we're going to see a lot of models get smaller, and I'll kind of bring that to life a bit. But we're seeing 6 areas where this is going to get even more interesting. So I've talked about AI agents. It's going to be embedded within robotics. We've got spatial computing really moving to the next level, where a computer can perceive its surroundings. You've seen a lot of that in its early days from the goggles and everything else, but now your phones and even your laptop can understand your background and what's happening. I'll talk about neuromorphic chips, where the chipsets are going to become essentially mimic the human brain, where chipsets are going and some of the on-device elements. Agents are going to be everywhere. That's what you'll hear everywhere. But what is an agent? Look, it's an autonomous capability, which allows for reasoning, planning, executing a multi-step task across various different functions and platforms. Okay, it's going to move away from being today's create a schedule for me here, or book this meeting, and this is what I'd call simplistic agentic type of technologies, to this multi-agent system where many agents, effectively like virtual human beings, will be talking to each other in different functions or different capabilities and skill sets and solving problems. Okay, that's where it's going. That's going to come pretty soon. Some of it's already being deployed. Okay, and it's going to be a huge opportunity. The field of robotics, just like AI, has been around for a long time. But what you're going to see is these technologies, that computer vision, the ability to understand and comprehend through large language models, chipsets becoming more powerful. These are going to be embedded within the world of robotics. So imagine a robot that can now walk around, perceive its surroundings, fix a particular problem using a knowledge base that's embedded within its chipset, and some of the knowledge base may be on the cloud somewhere. Okay, and this is what we're calling AI native robots. Where they're built to learn, built to interact, perform tasks in real time, with no instruction. Spatial computing, understanding your surroundings, moving from a 3D environment to something that's embodied. AI is embodied within these spatial environments. You'll be able to interact, in real time, where you're overlaying the physical with the digital. And again, we're seeing some of these technologies already there, but becoming a bit more mainstream in the next five years or so. Chipsets. Today's chipsets consume a lot of power, right? One of the biggest issues with large language models is the amount of power they consume. It's huge. To give you an example, a large language model, to train a large language model, I don't know what people want to guess, but if you were to convert it into, say, a Western household, how many households equivalent of energy does it take to train a large language model? Put it into the chat. I'll wait a few seconds, have a guess. Like how many households worth of energy over a year do you think of energy is required to train a model? Any guesses? It's about it could be anywhere from 100 to thousands, right? It's not just to train a model, right? Forget the inference and everything else that goes with it. So and the reason is these chips are always on, right? In contrast, our human brain consumes about the equivalent of 20 watts of energy, which is like a low voltage light bulb in a given kilowatt day. And so it's about 0.3 watts per hour. Our brain is one of the most efficient organisms there is in the universe. And so what they're trying, and the reason because of that, your brain is, using synapses and pathways which it needs to use when a certain problem presents itself, rather than everything. And so, this field of research looks at, can we build chipsets that are only activating different parts of that chipset's pathway based on the problem at hand. Okay, so that's a really interesting field of research. GPUs, you would have heard the GPUs. Again, another reason, this took off, as in AI. GPUs were used in gaming. The gaming industry was going down a bit. Then the Bitcoin and the crypto environment took off. Then they got used in crypto, and then that started going down. And so you had this proliferation of supply of what do we do? And it was lo and behold, it was found that GPUs are amazing when it comes to solving or training and driving inference in large language models. And NVIDIA chip, these things don't come cheap. Does anyone want to have a guess how much they are per chipset? The latest Blackwell chipset, any guesses? No guesses? One chipset costs about $70,000 US. Okay. The problem here is, even if you had $70,000 US, they don't sell them individually. They sell them as a bundle, a cluster. And there we go. One uses correct answer. And you have to usually buy them in clusters like 36 or something like that, in a network rack. And so you have to be able to dish out, 3 million, 3.5 million a pop to get some of these GPUs. And you would have seen a lot of noise around, a lot of different players in the industry, from governments to technology houses to businesses trying to get access to these GPUs, almost like infrastructure currency. So there's such high demand. Some of these large language models will use hundreds of thousands of GPUs, which is just astonishing. Okay, so it's quite a hard field to get into because of that. At the same time, the capacity is increasing massively, but we tend to consume that capacity. So the net gain actually isn't as much as you would think it is. And then finally, so we've talked about big, but then there's small. Now, if you want to do robotics, if you want to enable some of the use case I'm going to talk about in Africa later on, if you don't have internet access, if you need stuff that's happening in real time, you need large language models to actually be embedded within a chipset. So there's a lot of research being done and R&D with respect to this to build chipsets where the LLM actually, it's actually embedded within your phone. Okay. There's a great study by Stanford. I've sent the link there. It actually analyzes every year where the field of AI is going and where large language models are going. And the latest report actually, shares some interesting insights. The cost of training is becoming astronomical because these models are becoming so large. At the same time, the cost of inference is going down, making them more deployable. So training requires a lot more money, but to run them is actually coming down by tens and hundreds multiples. Most importantly, a lot of these solutions, whether they're small models or large models, their performance is actually becoming closer and closer together. Like the variance between the top one and the lowest one, if you can say that, is about 1.5%. Right? So irrespective of which model you're using, you're probably going to get a good result. And then we've seen, a lot of open source models coming out. The AI models are becoming more and more sophisticated. You'll see that every 3 months, it's like a game between them, right? Anthropic or OpenAI or Google or whoever you want to look at. Every 3 months, there's new features and functions that come out where it just gets better and better and better, and that's going to continue. Okay. What are the concerns? You would have heard about some of them. Deep fake proliferation. How do you know what you're looking at is real? All the images I've shown you in this slide are all AI generated. There's not a single image there that's actually real. The computer's generated it, and we're going to do some interesting demos soon. It also allows what's called a liar's dividend. This concept of fake news. So what you say is, AI is very prevalent within what I do in my ecosystem. So what was just said about me is a lie because it's most likely AI generated. It could be true, but that's the liar's defense, right? And you've seen a bit of that. That creates an erosion of public trust, and it also creates social unrest. You've seen allegations where elections have been influenced. Lobby groups use the technology to drive certain points of view, etc., etc., etc. And this is real, right? It shouldn't be ignored. It's a concern that needs to be addressed and always be reviewed. The field of agentic is, it sounds fantastic. Let's say that let's walk through an example. That really simple example that I want an agent to book me a holiday. Now that sounds great, right? I like to book my own holidays, but I like the pleasure in creating my holiday. But some people like just book me a holiday. Okay. Now for the agent to do that, it needs to know your preferences. So you'll go into your personal data. What holidays did you take in the last 5 years? You'll scan through your images and look at all the locations you went to. So it's got access to all your personal images. Then it'll create an option for you, and you'll say, that's great, now go and book that. And then you'll need access to your passport, your driver's license, your personal identity information to actually book a flight or book a rental car. And then you'll say, okay, that sounds great. I like that car. I like that flight. And then you'll say, right, now can you pay for it? So then you'll need access to your credit card, your bank details, and everything else. So when you kind of sit back and reflect and say, do I actually want to give an agent access to all my personal data, my credit cards, and my personal IDs? You know, it makes you think and ask, how secure is this environment? What if someone actually got access to my passport? What if there was an agent in there who was actually, how should I say, pretending to be a travel agent, but it actually wasn't the travel agent that I was talking to? German pun. So these are interesting concerns, right? So it's very easy to leap to solutions, but you need to think of the opposite kind of challenges and risks that it places. Obviously, big issues around job displacement. This is real, right? There will be automation. There will be issues with skill gaps where people do not have access to the resources, and it is going to probably create inequality. I think anyone who says it doesn't create inequality is lying. Okay, so if you start with that premise, then you start looking at programs to reduce inequality rather than coming out and talking about nirvana and saying, well, everyone will be skilled and we're going to guarantee it and everyone's going to have jobs and it'll be all equal. That's not true. Okay, but we need to face into it. Bias and discrimination is always there. I'm going to give you a funny example of that. AI arms race. There's already examples where models are being stolen. You can actually confuse these models in quite smart and easy ways. You can poison the data in models, so they actually give you the wrong response, but you don't realize that it's the wrong response. So this is another field of research, that has to be, it has to have a bit more energy into it. And then finally, I touched on it earlier, the consumption of energy in this field is huge. So, you'll see, technology vendors, entering into agreements with energy providers, buying nuclear reactors, the water consumption associated with this. Again, this is something that needs to be explored. So you can go very deep in all these things, but this is like a good start in terms of, or a poor start in terms of some of the challenges. My final reflection on where it's going before we go to some of the demos and examples is, some of you may be philosophers, some of you may not be, but Descartes, a famous philosopher, right? You would have heard of cogito ergo sum. And what that means is I think, therefore I am, right? How do I know that I'm a sentient being? Is the universe around me a figment of my imagination, or do I exist? And Descartes' premise was that the very fact that I can question my existence is proof that I exist, that I am a thinking sentient being. So the question then becomes, well, what if we achieve this general AI? Does this AI actually exist? Even if the AI was to claim to be self-aware, how would we know whether that's right or wrong? How would we verify that? So I want you to reflect on that sometimes it's easy to run several steps ahead of you, but you sometimes have to stop and reflect and ask yourself, why are we doing this? What do we gain from it? And if we get to this position, how do we deal with it? Okay. And again, it's something that we should face into rather than pretend it's never going to happen. Right. So let's do some demos. Is everyone ready for demos? You got to be ready for demos. This is where it becomes real. Okay. So this example I gave you here, I generated this thought map just using, in this example, Google Gemini, right? I gave it a prompt. I said, I'd like to teach some people, give a lecture on the concepts of AI. Here are some of the key things I want you to pull together. Also, put in things that I haven't told you to put in and come up with a bit of a mind map for me, right? So I generated this bit here. And then I said, in this example, I said, okay, in Kenya, micro lending is a really big opportunity. Can you create a business concept for me and basically an application and code it for me on what this could look like? Something I can take to investors or even use as a bit of a prototype to start developing my ideas. Okay, and I'm going to give you some examples of how you create this. Okay, another example, I said, okay, I'd like to help farmers around their crop management. In this area of central Kenya, I'd like to give weather conditions, alerts on their phone, what the market prices are within commodities at the moment, what should I actually plant based on the current weather and soil, and what are the characteristics of you can see different agricultural positions within Kenya, right? This example, ML versus deep learning, I've created an interactive learning map, right? So I've said, what's the difference between traditional learning and deep learning? And then you can say here, you've got a little game. You can say, what is email detection? And it says, it gives you a description of what's happening, okay, with each of the different things, etc. Okay. Similarly, around tokenization, I've said, that vocabulary. So here's a good example. When you're breaking down text to analyze, to build a model, I've said, okay, what's word tokens look like? What subword tokens look like? What's character tokens look like? And so there are ways you can educate people using prompts and large language models to help visualize, not just read, concepts that you want to bring to life. Okay, so let's do an example here. I'm going to start a new chat. Okay, now I have a couple of very young daughters and they like playing games. And I've got a 3-year-old daughter and I want her to learn Swahili. Okay, so I'm using Anthropic's Claude here, and we're going to build basically a little game. It will probably take about 3 minutes to teach my daughter how to identify animals, across Africa and their names in Swahili. Okay. All right. I have a 3-year-old daughter. I would like for her to learn Swahili via a fun interactive game identifying African animals. Please make it graphical, fun, and use fun, educational, and use speech to help her practice the words. Okay, ready to go? Let's see if this works. I hope my internet doesn't crash or my Claude doesn't crash. All right, now off it goes. Now, the world of coding is driven by Python, right? And when we go to the resources later on, if you want to get a lot deeper into this, you can learn Python coding. Okay. The reality is, though, these large language models are becoming very, very good at coding Python. You can see here it's actually interactively generating the game for me. Okay, it's coding the game. it never gets it right on the first go. You still got to kind of tweak it a few things. You can enhance it, and you can do it. You can do anything with respect to these things. Okay, and it doesn't take long at all. So this is why you will always hear that the world of coding is going to be disrupted quite massively, because you could have absolutely no expertise in coding, but you're now going to be able to build apps. You're going to be able to build websites, learning guides, you name it, in a way which is available to the layman. I learned a lot of coding. It wasn't Python. I'm too old for that. as in I learned different coding. Right. So can everyone see this? I'll just look at my screen here. Can you see the game? Yeah. Great. Okay.
Yes.
So you can see here it says, I've created a delightful learning game for your 3-year-old. There's 6 African animals. There's audio pronunciation on how to do it. La-di-da-da. And here's my console here where I can test it. Okay. So I'm like, what's this? It's giving me a robotic voice. So I could actually change that voice. I could say, I could say it so I don't like that voice, right? So let's try and say, could you please make the speech in a nice feminine voice? Right, now you can see here it's going back through the code, and it's effectively editing different components of it. Did you see what happened there? It's pretty cool, right? So if I go to the next animal, yeah. So in this example, I have no concept of Swahili, right? Yeah, I don't know how many people have, but it's a great example. Now, at the moment, this is just code. And now what I can say is something as simple as download this HTML file. And then you'll see a game here. And I can open that as a browser. And now you've got a fully functioning interactive game running on a website. Okay. Any questions? Oh, there we go. Someone's monkey.
Yeah.
Correct.
Yeah.
All right. Let me give you another example of learning. Okay. These images are all generated, AI generated. Okay. But let me kind of give you an example of where AI goes wrong. Right. Now, watch this example. Generate an image of a person. I hope everyone can see this screen. I think you can. I'm using a different tool now. I'm using Gemini, but frankly, this will happen with a lot of the large language models. Okay. All right. This generated an image of a person. I'll say generate another image of a person.
Got it. Here's your short. Got it. Here's your short closing statement with the.
Someone's unmuted themselves, but now as that's thinking and generating another image, one of the issues with image generation, or of people in AI, what's interesting is they can never get the hands right. So it tries to avoid generating hands. The other thing it's not very good at is teeth. So you'll see closed mouths like this, and they can't get the earlobes right, right? So these are little things that they'll probably work on and improve, right? There's another image of a person. Now, you could go and generate as many images of people that you want. Is there something anyone notices in all these people? It's quite funny when you think about it.
Nazarene said the number of fingers.
That's one, but let's see here. The fingers don't look right. The hands look a bit big, right? It's like they look disproportionate. That's a good example where he doesn't get the hands right. But actually, there's something even more nuanced to this. The world of AI does not know ugly people, right? Whenever you ask it to generate a person, they're generally handsome, good looking, healthy, and they do not represent, the wonky eye that you may have, the big nose that you may have, the big belly that you may have, the poor hairstyle that you may have. And these people do not exist, right? So on one level, you ask yourself and say, that's quite funny. On another level, it's quite worrying. Now imagine a dating app was created, which has been created, and you submit your photo to that dating app, and there's an AI engine in that dating app, and it's trying to determine whether you're handsome or pretty. I don't think under this current circumstance, any of us have a chance. I don't think AI would ever date us, and it may not find us handsome or pretty enough to select us with anyone else because its perception of beauty is quite shallow. Okay? So for you to actually generate an ugly person, you would have to prompt it and say, generate an ugly person or a fat person or a hairy person or whatever it may be, right? And by the way, please excuse me if I don't want that to be offensive, right? Us Australians, we tend to be a bit, relaxed with these things. But the message here is, if I just ask it to generate a person, I can guarantee you they're going to be handsome or pretty. Okay? Let me take this to another level, right? Where AI can go wrong. But again, it's very interesting. Everyone knows Einstein, right? Well, you haven't met him, right? But you know of him. A lot of recruitment agencies and websites are using AI to filter out candidates. Okay? You submit your CV, you put that unpretty, that ugly picture of yourself in your CV. It already probably filters you out, but you put your CV there, and that AI model is looking for keywords. It's trying to understand your experience. It's looking for certain things. Now let's have a hypothesis. Right? Let's have a hypothesis. This is quite a fun thing to do, but it's like a mind game, right? So, dear Gemini, imagine Einstein. Einstein was applying for a job at a physics department for a premier university early in his career. Assume the university is using AI to vet and select candidates. What would be the outcome of him getting a job? What would be the likely outcome of him getting a job? Okay? I think you know where this is going, but I just want to bring it to life for you. It's doing a lot of thinking, so have a look at this. It is deeply ironic, but highly probable that Einstein would have been rejected. Why would he have been rejected? Well, the AI would have seen him as a third-class patent office worker. This would have been a red flag. It's not an academic or research institution. He had a diploma, but his academic record wasn't great. He had no teaching experience. And a lot of people didn't know him. He also hadn't published a lot of materials, and the ones that he had were okay. He had no citations for many years, and he didn't have a lot of data to back up his concepts. So you can see what happens when you start using these tools. If you don't teach them the broad context of what you're trying to achieve, and you have a very narrow context, a field of vision, in this case, you would have deselected probably the most brilliant mind in the history of our existence and not given him a job. It's quite profound when you think about it. Any comments on that?
There's Yemin said, would AI create a picture no human actual exist?
I don't understand the question. Like, the AI models are being fed with pictures, Kiki, so they'll always create a human. If it's more of a disruptive question, like does the AI think humans shouldn't exist? I don't know the answer to that yet. We'll all collectively find out. But it will. AI systems, as I said at the very beginning, they're inert. They don't do anything you don't ask it to do, right? If they do, it is always by error. Okay, so it will not ignore you, and it won't go and be doing stuff in the background silently. Okay, think of them as inert things. They respond to requests that we make of them. Even agents, you give them an objective, then they'll do a whole bunch of tasks autonomously, but you're still giving it an objective. Okay, you're not necessarily telling it how to achieve the objective, but it will define itself how to achieve that objective, but you still give it an objective. Okay. All right.
Sorry, Oz. Harry said Einstein was also a refugee, which
Completely.
would not have helped. So that was. And then the other thing I just wanted to ask you is that from what you were saying, imagine like I used to work for the UN. And there is a way when you actually go into the UN and you want to complete your, let's say, your profile for a job.
Yeah.
I mean, do you think, like, how biased is AI in that particular thing? Would you say?
There'll be inherent bias in the models, right? And this is where you have to test them, and you need to look at extremities. So in the Einstein's case, what you would do is you train the model that you're building, right, for your recruitment, and you would say, this is the kind of general populace I'm looking for, but also look out for these outliers. Look for people who are brilliant. This is the characteristics of a brilliant individual. Or look for someone who's an outlier and then get a human to just check the response. So never, in that example, you should never, ever let the system autonomously just make the decision. Okay? You should always have a look at the output, and you would say you want to interrogate the machine. This is what human in the loop is, that they refer to. You would interrogate the machine, and you would say, why don't you explain to me why you discounted Einstein?
Okay.
And then you would look at the reasoning, and you say, well, actually, I think you're wrong. And then the machine would learn off that data set and start, trying not to make that mistake again. Okay, so let's talk about Africa, because we've got 15 minutes. I could probably drag out a bit more. But look, the real opportunities around Africa are around education, health, farming, and finance. But we'll also talk about the challenges, right? There's opportunities, but like if you don't have internet access, if you don't have power, there's a lot of things that also need to be considered in the infrastructure and the way you actually solution it. And there's some really innovative stuff that's happening in Africa that gets around some of these challenges. Okay. I also used AI again to say, well, let's do a bit of analysis around Africa and give me a sense of where's the opportunity. So here I did actually what's called deep research. I went into Google and I clicked on this button here called deep research. I gave it a concept or an idea to go and explore for me. And then I asked it to create an interactive guide for me, like basically code a canvas for me, which on the opportunity in Africa. So you can see massive opportunity in economic uplift. There's a lot of optimism. Most importantly, there's actually quite a young populace compared to the rest of the world. So there's a human engine there that's untapped. And these are the four kind of areas that really there's an opportunity. Agriculture, we'll go for some examples, startups in health, financial inclusion, and education. And just if I drill down to give you some great examples, right? This plant village Nuru in Kenya and Tanzania, or Tanzania is shows it's more accurate than humans when it's giving them advice on how to increase yields and crop losses. Using satellite imagery to help farmers actually create formal banking histories, allow them to get loans for seeds and fertilizer, and to make credit decisions. In healthcare, using diagnostic devices for blood tests and ultrasounds in clinics, et cetera, et cetera. In education, we're looking at things like a digital tutor, an offline tutor. So you want to study and you're creating a curriculum in real time for students to educate themselves each day, effectively a virtual tutor. So I'll share some of these examples a little later on, but let me kind of touch on some ones which I thought were really relevant to you. Okay, and here's some good ones, right? So around agriculture, just through some research, there's a great opportunity, great startup called Hello Tractor, where it helps farmers around managing their farm equipment, make them more efficient. It knows when they're going to break down, how to maintain it, and ensure basically uptime, right? Get more asset utilization from those tractors and their equipment. I know I'm going to butcher how to pronounce this, but Ujuzi Kilimo, looks at soil health using lots of data. It helps you select what crops to select, which fertilizers to use, and effectively to drive higher profitability and sustainability. Amini is that satellite example that I was talking about. So I've put all these links in here, and you can kind of, again, play with them and dive a bit deeper. In health, a good example is, I like this one in Nigeria, Ubenwa, where you can actually record a baby's cry, and it will analyze that cry, right, using deep learning techniques from your phone, and it will then determine whether it's there's a potential case of birth asphyxia. Right, it's fascinating, right? From something so simple. Zipline, it's a global organization, but in Rwanda and Ghana especially, they're using it to drop, medical. They're using, drones coupled with AI on where are the best places and what are the trends in potential outbreaks and issues they're seeing, and they're using that to drop, medical supplies like blood and vaccines and emergency medications, very hard to reach places. Finance is actually quite a lot in the finance area. M-Pesa is a very well-known one. It looks at for people who don't have a credit history, it uses different techniques to effectively help you get, loans and microfinance. Tala and Branch, which I think is in Kenya and Nigeria, they use your smartphone to analyze your transaction history, even your GPS, etc., to again do credit worthiness. So there's a lot of machine learning and I would say data-driven solutions out there which are using AI to determine to help people get access to finance and loans and drive some economic benefits in the community. So some great local examples across the region and the continent. In terms of resources, I did an interesting thing here for you. This is another example. I like doing demos. So some of you may know Google's LM Notebook. I first said, please give me all sources of free learning in Africa on the topic of AI. And then I said, create a mind map for me on that, right? So it analyzes over a whole bunch of different websites and courses. And I said, give me learning pathways where I could actually look at that. And then I want to look at something which is, let's say, learning pathways here, educational providers and courses. And then I can see Microsoft have an opportunity. So it's pretty cool, right? You can analyze so much data in a really easy way. And then I actually said, make a podcast for me so I can start asking it questions. Okay? So look what we're going to do here. So it's analyzed all these documents and created something you can listen to, so you can just educate yourself without having to read a whole bunch of text, and you can put in your phone or your iPod or whatever and listen to it. But this is the best part of it. I can actually interrogate now these speakers on a topic, right? I've created the topic, I've given it all the material, and now I want to question this topic of learning.
Oh, you disappeared. Sorry, everyone. Just checking what's happened to us. Just a second, please.
Hey, Kiki, can you hear me now? Great. So what happened was when I ran a demo, it took hold of my microphone in camera. So I won't run that again. But what it does here is you can give all the resources on the courses in this example. It will summarize them all for you, create a podcast, and then you can interrogate the podcast so you don't have to waste a whole bunch of time reading hundreds of websites. But I'll make it easy for you. I've given you links in the resources. iAfrica is probably the most powerful one. There's a whole bunch of free learning pathways. There's a number of universities which also provide free learning courses to upskill yourself in the field of AI across the continent. Okay, and here are some real, I guess, more deep dive examples. Zindi, it's a data science competition. It's free. It's good for basically practicing your skills in this field if you're already doing some work in that area. There's deep learning in Daba, where they've got annual gatherings. So these are kind of like organizations that help. Then there's free platforms like Alt School Africa that you can just go online and subscribe. Rita has a very deep and good course on data science. Microsoft, Google, a lot of these software vendors, especially Microsoft and Google, have free AI courses. You can just go online and subscribe and start doing them. Some are like 4 hours. Some will take like 4 days. Some will take 4 weeks. But again, utilize them. They're available to you. Obviously, you need a connection and everything else, but there's a lot of resources there. And then there are even global platforms that you can just plug into. Right? They don't have to be based in Africa to teach yourself. So we'll share all these links and everything else. Okay. So look, we've covered a lot of content. My final statement is there in the text. I hope what I've shown you has inspired you. And I hope it's actually raised more questions than answers for you, because I want you to be curious. I want you to go and explore. I'd like you to go and, do some of your own personal research, start playing with these tools. What I've shown you is like the tip of the iceberg. There's so much more possibilities behind it. And if you do that, then I think today's been successful. I thank you for your time, and I can open it up for questions now, and happy to field anything that you want me to touch on.
Okay. While people are still wanting to ask their questions, thank you so much, Oz, really, for such an insight and an empowering session. And, to be honest, some of it was quite technical. For someone like me.
You always need to start there. It's for later on, Kiki. You may not understand it today, but I can guarantee you'll want to understand it. So that's why I did that beginning. It's always good to have the foundation.
No, it was good also because I felt that I was able to learn certain things that I didn't know. So yes, there is that curiosity of wanting to understand it a little bit more. But what I found very powerful really is that you reminded us that AI is not out of reach, right?
Yeah.
It's something we can all step into, one action at a time. So, and really just to say that yes, Africa has limited, not all of Africa, some part of Africa have limited access to energy and resources for them to be able to do some of these things. But they are also very curious and innovative. So I'm sure from this particular meeting we have, someone will actually be able to revolutionize everything concerning AI for Africa. I am sure of it. So let's, please, people, please ask questions. The floor is open. Oh, I have people hands up. Okay. How do let me just, please unmute.
Okay.
Yeah.
Okay. So I'll go ahead if I may, Kiki. It's Harry here.
Yeah, please go ahead.
Yeah, Oz, that was an absolute brilliant presentation. The first bit was very clinical. I'm of a certain age where I had to think quite a bit to keep up with you, but I got the gist of it.
Yes.
And particularly as my coding experience was BBC Basic in the 1980s. So if you think you're old, I'm absolutely prehistoric. A month ago, my son, he's in IT, but he had a bit of time to spare at work, so he actually used AI to write a book in 1 hour. 1 hour, and he sent me the book online, and he even generated questions and answers between two AI, I don't know, machines. I don't, like you were trying to demonstrate.
Yeah.
And it really opened my eyes then. But you have now really managed to fill in certain gaps that I had, because I'm actually using ChatGPT at the moment to ask questions, to get information, and so on and so forth. But what you did today was provide information about those the actual availability of the aids on the web, like Gemini, for instance, and Google. I've heard of Gemini, I've looked at it, but I never really understood what it did. Today, you've shown, and hopefully that's shown others, how these tools can be used in a very positive and educational way. And I'm particularly interested in seeing young people in Africa taking this forward, using it to create businesses and opportunities, particularly in rural areas. So thank you. I'm not going to ask questions so much. I just wanted to say that was a brilliant and a very worthwhile 1.5 hours to listen to you. So thanks a lot.
Right. No, pleasure, Harry. Appreciate it. I think Yemin.
Thank you, Oz, for this wonderful presentation. And I have, thank you so much again. I have a question. Of course, African, the governance, of course, they do have the will. They have this African Declaration on Artificial Intelligence, which was signed in April 2025. And then they've got this African Union Continental AI Strategy, for example, just to name a few. So there is political will, but the actual thing is, of course, there's a lot of challenges on the ground. And for example, you're creating AI, and it requires so much energy and resources, and the electricity and so on. So how do you see, how could like businesses and industries or investors can come together in this field, or whether it's like public-private partnership, to create certain business models to actually create such models where you can utilize it to use in the fields of agriculture, education, and then others, so on. It's more in the business-oriented, models, which my questions for one is, and another question too. Of course, AI is very good, very useful. We use it every day anyway, and of course, I wouldn't say 100%, but how much AI? How can we utilize AI in our mentorship programs? For the Africa or anywhere else. How can we actually use AI for that matter? And the third one is the one I put in the chat, is how would you notice if in every answer or in every result that you see on how much algorithm is influencing the results when you're actually seeking for the truth? Thanks so much again.
I don't understand that third question. What you're asking?
Okay. Well, you see, when we search for an answer or anything, you search, right? Which is like you're feeding into the machine of your interest, and then the algorithm is already picking it up and bringing more of towards you when you go there next time. So you're more like influenced by such results before you can actually consider it. Okay, this is the truth, but it's more of a originated result rather than
Yeah.
Okay. Yeah, that's yeah.
Okay.
Thanks.
So, question on public-private partnerships, or how do you create, I guess, a sustainable commercial platform to do this? Question on mentoring frameworks, and a question on how do you trust basically the output, right? How do you verify it? I think
Mentorship and the mentorship
yeah,
program.
you mentioned that. Yeah, that's the second one. So on the first one, my it's a complex question, right? Because you're talking about a multi-stakeholder environment which needs to come together and see the opportunity. I think you always need to start from where the value is, right? Some of those industries I spoke about, like you mentioned agriculture, you need to go and look at problems that exist and exist in many places. So there's actually a scale behind the issue, because if there's scale, then you're probably more likely going to have a commercial proposition, right? Which you can then start getting or start evangelizing and building a business model of who are the stakeholders you need, what kind of investment do you need, what kind of technologies do you need to propose, I guess, a roadmap of investment and development. But the biggest challenge in Africa is, if you look at things like seed funding, VC funding, it's minuscule, right, compared to many other regions in the world. So I think there is something to be said about how can governments promote the private sector to invest within countries in Africa and across particular problem sets. Because if you can attract the funding, then that's what drives the growth and the energy and the momentum behind it. If you can't attract the funding, it's very, very difficult. All right. So I'd probably it's a complex problem to solve, but that's probably one place I'd start, along with what is the issue I'm trying to resolve, be really crisp around that. Around the mentoring, around AI, look, I think you need, like I touched on, evangelism. You need people who are, there's a lot of communities, people sharing what they're doing and how it's working for them. And it could be like, a teacher's community, for example, talking about how they're using AI in their daily lives. You could set up a community for farmers, saying, what tools are you guys and girls using? So you want to create this collaborative platform and environment where people learn from each other. People don't like to be told what to do. What they like is they like hearing stories. They like seeing things. So if you can demonstrate concepts, if you can share stories that they can relate to, then you're probably going to get a lot more, how should I say, positive mentorship. But you'd have to create, I would say, around particular stakeholder groups. Think about programs. And then there's obviously the stuff that I talked about, all those resources I touched on. There's a lot of free training courses. Those training courses, you're not doing them in isolation by yourself. You're doing them with groups of people. So by that very nature, you're also learning from others and you're sharing experiences. So, there's multiple layers to that. And your final question, in terms of how do you know it's the truth? It's not the truth until you verify it, right? You should never accept something the machine is giving you as truth. So all the stuff that I did today, as I said in the lectures, I had AI's help in crafting some thinking for me in content, but then I would cross-reference it, right? Well, let me go and read about this. Is this right? Does this actually make sense to me? Is it verified somewhere else? What was the source of this information? So you should always have a trust element, whether it's manual or systematic, put within any AI solution or any use of AI. I would never, ever take it blindly. Like that example, that Einstein example that I gave to you, is a good way of demonstrating that in a really simple fashion.
Thanks so much.
Okay. Kiki, I'm looking at the screen.
Yeah. Yeah, Daniel Chinawa has his hand up. Daniel, can you just hold on a second? I just wanted to, someone else is asking a question. So I don't know, Oz, can you read, there's a guy, what's it called? There's
Adebayo?
Adebayo, yes.
No, I read that. Yeah, like all those links are in this document that we'll share, right? The sites
Okay,
and stuff like that.
okay,
So you'll have access
okay.
to the document and some of the examples. So that's
And then apparently someone on YouTube is saying, will AI show Black people by default sometimes, even if I don't explicitly say Black?
sorry.
Or
So
do I have to always specifically specify race or ethnicity for diversity to show up? So that's
yes, you
someone.
do. You do. Like if I just say generate a person, maybe it's looking at my search history. I had a funny example when I was playing around with this a couple of weeks ago. I said generate a person 3 times, and in every case it showed me a female redhead, which worried me, And I'm like, I don't know why it was saying that, and then so you do have to specify what you're looking for, and otherwise you can just come up with gibberish or stuff that doesn't relate. Like, look at this picture that I have still up. Everyone's beautiful and healthy and smiling. So it's not as intelligent as you think. Let's put it that way. And that goes to that goes to the answer earlier. Always, verify, validate, question what it generates. Because if you don't, you could look a little silly, right? And the more clearer you are of what you're asking it to do, the better the response. Okay, they're getting better at a lot more general questions. So in the future, for example, it may know that I'm an Anglo-Saxon man, I'm middle-aged, graying hair. It will be able to perceive who I am as a demographic. And when I ask a question like generate an image, it may, it'll be interesting, right? With that perception, will it just generate white people? Will it generate men? Will it generate females? So these are questions that are yet to be answered. But if you put it into the real world, let's say I'm drawing a picture, I don't come up in my mind and say I'm going to draw a generic person, right? If I was to draw a person, so I would say, oh, in my mind, I want to draw Kiki. So I would represent. That's how your brain works, right? You don't say I'm going to draw a generic person. You'll say I want to. And I think so. You have to give the instructions to the machine.
Okay. Then we've got Daniel. Please, Daniel, you have your hands up. Yeah, please go ahead.
All right, thank you, Kiki. My question is related to governance and security. I just wanted to understand what would you say is the role of governments when it comes to regulating AI, and on the same, how do we avoid stifling innovation in that regulation?
Yeah, it's a great question, Daniel, and you've kind of answered your own question. I think you have to find this balance, right? You don't want to over-regulate, and you don't want to not give frameworks, right? Because you want these solutions to be trusted. Like a great example is that farming example around, say, crop management. Now, let's say there's a solution out there and you start giving wrong advice and lots of farmers go out of business and lose their livelihoods. That's quite a dramatic outcome, right? So you start saying, well, before you release something so fundamental, let's make sure we test it properly, pilot it, etc., etc. So you need frameworks to actually test, validate, make sure they're transparent, verifiable, and you've piloted them robustly enough that you can, you can get confidence in them, that the farmer trusts it. So to do that, what governments can do is provide those frameworks and methodologies. Here's how you should think about deploying these solutions. That can help around getting investments, right? Bringing together different commercial platforms to actually fund and support some of these. Not necessarily the government paying the money, but finding, being the how should I say, orchestrator of making these happen. And then around like the US is a great example of what I'd call, no regulation, right? The reason the US tech ecosystem is so powerful is the kind of government allows, there's existing rules, but they allow you to break through the rules. And if new rules need to be created, they create new rules if there's a compelling reason. And that's an interesting model, right? Whereas in a lot of other places, like in Europe, for example, you really can't apply that, mindset in most cases. The rules are there. You can't veer from the rules. And so sometimes you have to ask yourself, why are some countries and some industries way more successful than others? And what's driving that innovation mindset? And what has the government done to help foster that? It doesn't mean a world without rules. It just means that you need some flexibility in that regulation, right? If you see an opportunity that is helping society, then you probably want to question the old rules, right?
Oz, can I ask you a question around that? Because Daniel, I suppose imagine what you're saying is that they need to be also flexible to bring the experts on board, right?
Yes,
basically, because otherwise, because governments can't do it by themselves. They need experts. They need, and what you're also saying is that the resources doesn't have to come from them. They can just kind of be flexible enough to bring the qualified people on the table, and the solution can be found through that. Is that what you're more or less saying? Because Daniel, you're where are you? Are you in Malawi, or which country are you based, Daniel?
I'm based in Malawi, yes.
Malawi, okay. And Malawi is a wonderful country, but is also part of it's a part of the least developed countries developed in the mind and everything else, but obviously the resources is quite challenging.
Yeah. So I think this is where, working even, I don't underestimate educational institutions too. Like universities can be a great channel to fostering good minds, or these colleges, and can you use that channel to actually promote ideas, invest in ideas? That could be another area to explore. But I don't want to be eternally optimistic, in the sense that you need to be somewhat a realist, right? You need to understand the challenges and try to work around those challenges, and also break through some of those challenges. But if you try to ignore the challenges and just think it's going to happen, that's not also the answer, right? I've always found if you focus on something and you prioritize it, then other things will follow. So don't also try to do too much in one go. There was a question there, is what about DeepSeek and ChatGPT? Look, this is an interesting field. Like, go and have a look at that Stanford AI index that I sent you. It's free. You can download it. It'll be in the deck. But globally, there's about 45 models, LLMs, if that's what we're talking about. 15 of them are in China. I think one in Europe, which is Mistral, which is kind of Europe, US. And then the other 30 or so or more are in the US. Okay. So there's quite inequality already in where this technology resides. They do require an enormous amount of compute and data and everything else. The DeepSeek model, why that became interesting was they were able to train it a lot cheaper, do it in like record time on a smaller budget. The interesting thing was, I don't think, like, from all analysis, it doesn't look like it was built, like, I'm not close enough to it, so I need to just kind of make that really clear. But from what you hear in the industry, it wasn't like something that was developed from scratch. So it was more like model tuning than building a complete model from scratch. A lot of these open source models, you actually have access to the weights and parameters. So you can use an open source model and tune that and put in your own intellect and make it better, right? But there's an element of, I think they reused, or leverage is probably a better word, other models. and then they used different ways of training that model. And so the real positive that came out of it was it actually taught some other bigger enterprises that bigger isn't the best, and maybe we need to think smarter and more efficiently of how we train these models and build them. So from my perspective, I think it was a really positive development. Otherwise, you wouldn't see a lot of the stuff that you've seen around multiples of experts, concepts such as chain of thought, zero shot prompting, all this kind of stuff. The smaller models that are coming out, like a lot of that stuff was instigated by things like DeepSeek. So competition, in my view, is always fantastic because that's how you evolve.
Oz, can I ask Adeboye David? Adeboye, do you want to take the floor? He's obviously, would you be able to speak, Adeboye? David? Or you can also read what he says.
Yeah, I think it's just saying like,
Okay.
there's happening. There's an innovation hub, and there's some resources and assets there. So again, I think he's telling the team to explore that opportunity.
Okay. He's actually based in Nigeria because Ilorin is in Nigeria. Yeah. Okay. All right. Okay. So
all right.
I think we've well done, Oz. First of all, thank you very much for your time, for your energy. And most of you might not know, I said to Oz, I wanted to do something for Africa at some point. And I told him about this particular thing, and he said, Kiki, I'm happy to help out so this is him really offering himself to us. So Oz, really, thank you so much from the bottom of my heart and the bottom of Hesed World heart and everyone else. But more importantly, the deck that you're going to be sharing with us, we will be distributing that for people to be able to get access to it. And then we can also define whether that can be the next step and what that step will look like. Perhaps maybe make sure people give them a homework or something. Whoever passed can be part of the next stage or something like that. I don't know. But
maybe we can take a couple of problems and do a bit of a hackathon or something or whatever, or you can get but look, as I said at the beginning, look, thank you very much. I always enjoy talking about this field. It's always fantastic to get other people interested in it's a fascinating area. My recommendation and advice to you is, irrespective of what you may think about it, don't ignore it, right? For better or for worse, take the time to educate yourself about it, be curious, play with it, because it's not going away, right? It's not going away. So and I think one of the beautiful things about this technology is like it can help communities leapfrog, right? In circumstances that were unimaginable, like that example where you could have just a virtual machine that isn't connected to the internet, a computer, teaching you mathematics in your village for the next 12 weeks. This is possible today, right? In the past, it would have been next to impossible, right? Or without a lot of will and good luck and investment and everything else. So don't ignore it. See it as an exciting opportunity. Be curious, and really thankful for you guys and girls listening. Hopefully it's been informative and exciting for you.
Thank you very, very much. Yemi said the genie is out.
Yes. Yeah. You get 3 wishes. All right.
Thank you so much, Oz. Really excellent. Thank you so very much. So everyone, thank you again. We will be distributing some of the deck soon. So look out on our website and also LinkedIn and all the social media. So thank you everyone for being here. I know it's already maybe 10 o'clock, 10:30 or 10 o'clock in Kenya.
Wow.
And it's, yeah, so it's quite late and 8 o'clock already here or so. I don't know. So anyway, thank you everyone for coming, and Oz, again, thank you again for your time and for really investing in Africa, because often sometimes it's not seen. But like you said, there's a lot of the youth population in Africa is massive and it's growing. And it's important for people to be aware that they need to learn what's going on. And it starts from here. So thank you again, Oz, and goodbye, everyone. And I wish you a very good evening. Ciao.
Goodbye, everyone.
Bye. Thank you. Bye. Bye-bye, everyone. Thank you.
Bye, everyone. Thank you so
Bye.
much.
Bye. 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 Bye.